Okie dokie. Today we're going to be deriving the relativistic kinetic energy equation and the total energy equation, relativistic total energy equation. So let's get started here. I'm going to use an abbreviation. Square root means this right here, all of that. And square root squared, of course, means this squared, which would be this. The relativistic energy, total energy equation is m sub 0 c squared divided by this square root right here, which we're using the abbreviation. And the relativistic momentum is right here. All right, so we'll square this, which means we square this, and we square this, and square this. Then we'll take this guy and subtract off this guy. There's this guy minus this guy right here. Okay, and that equals this guy over this minus this over this. And if you take out m sub 0 squared and c to the fourth out, you'll get $1 right there, minus, and we're going to take those two out. If we take it out of there, you get m sub 0 c squared, and so there's the c to the fourth, and if you take c to the fourth out of this, m sub 0 squared is right here, and if you take c to the fourth out of this, you'll get this island right here. So this minus this will give you this right here. And if we notice, this guy squared, the square root squared, I told you up here, is this guy, and that guy is this. So these two cancel. This cancels with this. So you're just left with m sub 0 squared c to the fourth, which I wrote right here. And you have E total squared minus momentum squared times the speed of light squared. Those people are right here. So this is the relativistic equation for the total energy as a function of momentum and a rest mass, okay? And we can write that like this. Okay, let's take a look at now at the, so this is our equation, or either of these equations are relativistic equations that we can utilize. So let's take a look at the next derivation that we need really quickly, and that is the kinetic energy. So kinetic energy is equal to force times distance. We'll take the differential of that. Differential of kinetic energy equals force times dx. We're going to go and integrate this, and we get this. That equals the integral of this, which I wrote right here. Force, we'll need to know what force is. Force is the derivative of momentum divided by time. And momentum is m times v, of course. That's relativistic m. And so I wrote right here that the force equals the derivative of the momentum divided by time, or derivative, the differential of time. So the derivative of the momentum divided by the derivative with respect to time. And then we're going to plug this back into right here into the integral for kinetic energy, F. So who's F? He's all of this. So here's the kinetic energy. There's the equals. There's the integral. Who is F? F is equal to this. So there I wrote all of F right here. That's this written right here. And then the dx right there is sitting right there. So this integral has been transformed with these substitutions into this integral. And dx over dt is equal to velocity. and then this guy will just move in the back. We'll do integration by parts to solve this problem. And in order to do integration by parts on this, we'll call this Mr. F and this Mr. G inside the differential d whatever. And we'll have this is our formula for kinetic energy, and that equals F times G minus the integral of G times dF. The kinetic energy, of course, is this right here. Is the kinetic energy of a particle. Okay, so there's this is right here, and I'm sorry. By the way, F times G. That's F times G right there is this, minus, there's the minus, the integral of G, remember G was the inside stuff here, m sub 0 V divided by the square root, which is over there. That's this, that's G, and then dF, remember that F was equal to V, so dF will be dV. So this equation, which is integration of the equation for integration by parts, as long as you choose the right people, F is V, G is m sub 0 V divided by the square root. We will get this integration by parts general formula will turn into this specific formula for our problem here. And we can do this integral fairly easy. There's this stuff right here, plus this integral right here. And the integral of this is this right here. And we'll evaluate that from velocity equal to 0 to velocity equal to V. Stick in V into here, and you get all of this again, minus, stick in 0 into here, and you'll get m sub 0 V c squared. All right. So, therefore, we're going to have this plus this is going to give you this right here. This is step 11, step 12. Give me this. Kinetic energy equals rest mass c squared divided by the square root, which is this, minus m sub 0 c squared, which is the rest energy of the particle. Okay, and that's and then this can be rewritten if we simplify to kinetic energy is equal to E total minus m sub 0 c squared. So this is our kinetic energy formula, and this is our total energy formula. Well, I hope you enjoyed this video. I look forward to any comments at the bottom. Thank you very much for watching.